Hello and welcome to Maths with Udom. I still remain your online mathematics tutor, Mr. Okon Udom. Today, we are going to look at subtraction of fractions, okay, with different denominators. Subtraction of fractions with different denominators, okay? So let's start. Subtraction of fractions with different denominators. Okay, so subtraction of fractions with different denominators. Let's get it underlined. Okay, the way we did addition of fraction with different denominators is exactly the same way we are going to solve problem in this regard. The only difference is that instead of adding, we subtract because we have subtraction. Okay, now let's look at some examples on how to solve problem on subtraction of fractions with different denominators. All you need to do is to first find the LCM of the denominators and then use the LCM to simplify such fractions. Okay, so let's have our examples. Okay, our example is that we are going to simplify the following fractions. Okay, so we are going to simplify the following fractions. So what are the fractions? Okay, let's underline this. Number 1, we have 7 divided by 10 minus 4 divided by 15. Number 2, we have 11 divided by 15 minus 2 divided by 5. Number 3, we have 7 divided by 12 minus 3 divided by 8. And lastly, number 4, we have 5 divided by 6 minus a whole number 3. Okay? So what do we do? Solution. Number 1. So we have 7 divided by 10 minus 4 divided by what? 15. Okay? Now we find the LCM of 10 and 15. That's the first thing to do. We first find the LCM of the denominator 10 and 15. So let's do it in this column. 10 and 15. Okay? So what can go? 2. 2 in 10, 5. What can go? Can 2 go in 15? No, you repeat that. What can go here? 3. 3 in 5, you repeat 5. It's impossible. 3 in 15, 5. What can go? 5. 5 in 5, 1 and then 1. So what do? We circle our what? Our prime factors. Okay, so our LCM will now be what? 2 times 3 times 5. 2 times 3 times 5. So what is 2 times 3? 6. And 6 times 5 will give us what? 30. So our LCM is 30. Then we'll come here and put our 30 under. Okay? So how many 10 can go in 30? 3. So 3 times our numerator 7. Okay? Minus how many 15 can go in 30? 15 in 30 is what? Is 2. So 2 times our numerator what? 4. Then we'll come to this side and we'll write 3 times 7 is what? 14. No, 3 times 7 is what? 21. Okay, let's clean this side. Okay, so numerator 3 times 7 is 21 minus 2 times 4 is what? 8. Is that okay? Alright. Everything divided by what? Our denominator 30. So 21 divided by 8 will give us what? 13. So 13 divided by what? 30. So if we check through this fraction, you will discover that what? You will discover that our answer is in proper fraction. Okay, it's in proper fraction. So what do we do with this? You leave the answer the way it is. Okay. What happened? What if? Okay, let's move to number 2. There's no second method on this because they have different denominators. Okay, they have different denominators. I wanted to give you second method. I just remembered that it's only one method we can use. All right. Number 2 example. We have what? 11 over 15. Take away 2 over 5. So the first thing to do is to work out our LCM in this corner. So let's work out our LCM in this corner. So we have 15 and 5. 15 and 5. So what is the LCM? 3 can go here. So how many 3 can go in 15? 5. 3 in 5, impossible. Then 5 can go. How many 5 in 5? 1 and 1. So our LCM is what? Is 3 times 5. So LCM is 3 times 5. And 3 times 5 is what? 15. So what do we do with that? We come to this side and we write 15. So how many 15 can go in 15? 1. 1 times our numerator 11 minus, remember we are doing subtraction. How many 5 can go in 15? 5 in 15 is what? 3. Why 3 times our numerator 2? Okay? So what do we do next? We multiply the numerators. So 1 times 11 is 11. Take away 3 times 2 is what? Is 6. Everything divided by what? Our denominator. Okay? So 11 take away 6. That will give us what? That will give us 5. Am I right? Yes, 5. So that will be 5 divided by what? 15. Okay? We cannot leave the answer this way because 5 can still go through the both numbers. Okay? We have common factors, which is 5. So 5 here 1, 5 here 3. So our final answer is 1 over 3. 1 over 3, which is what? A proper fraction. Is that okay? Very clear. That's good. Let's move to the next example, example 3. Okay? Example 3. Let me use this one. So what do we do here? For example 3, we have 7 over 12 minus 3 over 8. So the first thing to do is to find the LCM of find the LCM of 12 and 8. So what is the LCM of 12 and 8? We come to this corner, we write 12 and we write what? 8. So what can go here? 2. So 2 in 12 is what? Is 6. While 2 in 8 is 4. 2 can go again. 2 in 3. 2 in 6 is 3. 2 in 4 is 2. 2 can go again. Can 2 go in 3? No, you repeat the 3. 2 in 2 is 1. Then 3. 3 in 3 is 1. 3 in 1 is 1. So what do? We multiply all the factors outside to get our what? LCM. So what do? Our LCM will now be what? 2 times 2 times 2 times 3. That will be 2 times 2 times 2 times 3. Okay? So what is 2 times 2? 4. 4 times 2, 8. 8 times 3 is what? 24. So our LCM is 24. Then we'll now come here, and what do we do with that LCM? We will write our division line and put our LCM 24 under it. So how many 12 can go in 24? It is 2. So 2 multiplied by our numerator was 7 minus. How many 8 can go in 24? 3. So write 3 multiplied by our numerator was 3. Then we'll come to this side and continue. So let's multiply the numerator. 2 times 7 is what? 14. So 14, take away 3 times 3 is what? 9. Okay? And that will give us, divided by what? 20 what? 24. Now, what is 14 divided by 9? 14 divided by 9 will give us 5. Okay? So we have 5 divided by what? 24. And that is how to solve such problem. Okay? We have gotten a proper fraction. Okay? And lastly, we move to number 4, which is our last example for this class. Okay? Now, for the last example, there's something I want us to notice because it's different from the others. Why is it different from the others? Example 4. What do we have there? Okay? We have 5 over 6 minus what? 3. This 3 is the whole number. Every whole number, they have 1 as their denominator. So I will write 3 over 1. So what is the LCM of 6 and 1? The LCM of 6 and 1 is still what? Is still 6. So how many 6 can go in 6? 1. Okay, so 1 times our numerator 5 minus how many 1 can go in 6? 6. So 6 times our numerator 3. So what do we have? We now come here and continue. So 1 times 5 is 5. Take away 6 times 3 is what? 18. Can you see that? Everything divided by what? Our denominator 6. Okay? Now, if we look at the numerator here, 5 take away 18 is impossible. So what do? If you write minus, then you write the bigger number, 18, minus the smaller number, 5. Everything divided by 6. And that will give us minus. 18 take away 5 will give us what? 13. Okay? So we have minus 13 over 6, which is an improper fraction. Okay? An improper fraction. So what do we do with this? We change this to a mixed fraction. So that will give us equals to minus. How many 6 can go in 13? 1. So 1 whole number. Remember what? Remember 7. Everything divided by what? Divided by 6. No? Sorry for that. How many 6 can go in 13? 2. Because 6 times 2 is 12. So write 2. Okay, 12. Remember what? Remember 1 divided by 6. Okay, so that's our final answer. It's a mixed fraction with a negative sign. Okay, so it's a special case. Alright, so we have come to the end of the examples. Let's move straight to assignments. Assignments. So remember how we solved those problems. We started with what? Getting the LCM. And from the LCM, we use the value of the LCM to simplify further to get what? Our final answer. Is that okay? So the assignments. The assignment is that we have to simplify the following fractions. Simplify these fractions. Okay? Let's have the assignment right away. Number 1. What do we have there? We have 5 over 6. Take away 2 over 9. Number 2. 5 over 7. take away 3 over 4. Okay? Number 3, we have 3 over 7 minus 6. Number 4, we have 3 over 4 minus 1 over 12. And finally, number 5. Okay, what do we have? 4 over 5, take away 2 over 3. So these are your assignments. Okay, all you need to do is to solve these assignments, submit the assignments to your school teachers for appropriate markings and corrections, and by so doing you will get better by the day. Okay, so before you leave, kindly like this video, drop your comment in the comment section, share this video to all your friends and family members all over the world, and most importantly, subscribe to our YouTube channel. Remember, the best way and the only way to become a mathematician is by constant practice. Practice mathematics every day and then you become better. Until I come your way again next time, my name still remains Mathematician Okon Udom, and I'm saying to you, remain mathematically smart. See you in my next class. Bye for now.